The second major approach that I want to talk about handling is the use of exceptions. Exceptions are like return codes. Exceptions are used for handling things which can legitimately occur, which are based on things outside of programmers' control, which are not merely due to programmer oversight or reasoning problems, but are aspects of working in a world where we've got uncertain things happening. But in contrast to return codes, exceptions, ladies and gentlemen, are used to handle unexpected and rare events. Can anyone tell me why? Why not use exceptions to handle, after all, well, okay, exceptions have the virtue of essentially forcing you to handle them. Not just blithely ignoring them, but actually forcing you to kind of explicitly take them into account. So why not use them instead of return codes? A primary issue, ladies and gentlemen, is performance. Perhaps that's the biggest issue. Okay? It's a performance issue. Exceptions are heavier weight. They can really slow down a program in some cases if you're using them very frequently. If you're only using them occasionally, minuscule, and they serve very useful. So return codes are not really provided with any sort of special language support. They're handling common events. Exceptions are given explicit language support. They're built into Java. They're built into C++. They're built into many other languages as well. They are not built in any robust capacity into C. Okay. You have set jump and long jump, which are crude, sort of pale ciphers, which are also dangerous because they don't clean up after memory that's been allocated. So basically, you could view C as not being a language with any sort of significant exception handling. So I want to contrast here the cases that we talked about earlier, cases which are basically common: end of file, last item of language, dictionary key not found. This might occur many, many times. Versus cases which are more uncommon, but we've got to be able to handle it for our program to be robust. We don't have control over what generates these sort of situations, and because we live in an ugly world, we got to sometimes handle inconvenient things. So an example would be memory loss. The disk is full. The network is unavailable. There's a connection timeout. There's a broken connection. We're connected to this resource and now it's broken. We have an invalid typecast. I take that back. I'm going to remove that. That really should give insertions. I don't. Well, it can occur in some cases, but that's a subtle thing. So let me edit this before your eyes. Out of glass spot. File not found. Data corruption. These are things which are dealing with them. We've got to be able to deal with them if we're going to have a really robust program. We don't have the option of living in a world where we can enforce that everyone is in memory, or that everyone's disk is arbitrarily large, or that everyone gives us, terabytes of disk space or what have you. That's not feasible. So we have these exceptional conditions. These conditions which occur occasionally, and we have to be able to handle them, but they don't occur, many, many times a second or something like that. So, exceptions are used to handle, again, cases where things go wrong in the execution of code. And we want some sort of way, a distinguished way, of signaling that something's gone wrong. To stop normal processing of code, and to get someone to handle this awkward situation. Because we may not know how to handle it. So, we have a function that says connect. Maybe it's connect to a database, and it can't find the database. It wants to say, help, help me, tell me what to do. Maybe it's have the user, correct the name of the database, or maybe it's to go look for a backup database, a database that's an alternative database, a fallback database. But fundamentally, we may be in a bit of code that doesn't know how to handle it. We're seeing ceding control to, we're ceding authority to, we're appealing to other pieces of code to kind of help us out with this awkward situation. Or at the least, clean up after ourselves. Close files, close connections, and bow out gracefully. And give a message user return conflict your task. Right? So we want to go up, sort of have someone else handle it. Here we do so by throwing something called an exception. And this is in Java, it's in C++, but it's in probably now dozens of other languages, including lots of common. So the idea here is that we have one place where exceptions are thrown as in the sense that they are triggered, and then we have other places which handle those exceptions, which, in some sense, clean up after them. Okay? And the way this propagates, ladies and gentlemen, is on. I always feel like at this point I risk of losing people because I'm descending into nerdese, but I'm not sure I live outside of nerdese. I used to have a nerd pride button that I would wear around. They give about it to you actually. They're popular items, but I give it to one professors who are retired. So suppose we have foo, and foo calls bar, okay? And I'm actually going to show this, first one to its name. Foo will call bar, or maybe main calls foo, okay? Main calls foo. Foo calls bar. Bar calls what? Baz. And Baz calls zap. Here you see the tower of the tower of geeks. The tower of geekies. This is sort of a canonical ordering that's been well established in the history of computation. So we have name called foo call bar call baz, and baz call zap. Now, ladies and gentlemen, if things go normally and we just have things returning, zap will return and then we'll continue on and execute baz, and then baz will return and bar will continue to execute, and bar will return and foo will continue to execute, and good things happen, and eventually get back to the main function. Right? Are people comfortable with that? One thing calls another. Now, I'm hiding some awkwardness, and I could take delight in talking about recursion, etc., but I'm not going to do that now. Instead, what can happen is, let's suppose something goes wrong in Zap. Maybe we told Zap to go off and grab the current temperature in Saskatoon from a certain weather station, or for that matter, from the Government of Canada, Environment Canada website to grab the current temperature, right? Current air temperature in Saskatoon. And Zap can't do its job. There's no network connection available. Could that happen? Yeah, it could happen. I know you folks are the connected generation. Believe me, there will be times in your lives when you cannot be connected. And you know, it's a reality that if you're going to build software, you got to be able to handle this. People go into subway tunnels, folks. They drive to areas outside of cell coverage. They go into certain types of structures where the cell towers can't penetrate, etc. And you're going to lose cell phone connection. Okay, so Zap here, if something goes wrong, if it can't connect, what it does here is it throws an exception. Okay? Now, this is different from the case of returning a return value. This is something that leads to a different path of execution. And as we say, it rolls back the stack. So Zap says, hey, I can't connect with this exception. It doesn't come back in the sort of normal way, just returning the value or just returning. It comes back some alternate way, an exceptional mechanism, labeled with E, okay? And it says, hey, I can't do this job. And it sort of goes up to Baz, and Baz says, oh, I got this exception from this guy. I got this exception from Zap or from this block of code. What am I to do? Now, how do we actually encode this? Well, we have something like this. We have a try statement. So maybe Baz has this try statement. And inside this try block, it calls Zap. And so Baz is here, and Baz gets back exception. So it's trying to execute this try block up there. Trying to look through each thing, and it's gotten to this call to Zap, and that call to Zap, ladies and gentlemen, didn't just return. So it doesn't, maybe in Baz it was calling in this try, it was calling, it did some work, and then it called off to Zap, and then it did some more work, etc. And it gets here, and Zap bombs out with an exception. It just says, bad things have happened, handle this. And what's going to happen is, instead of just continuing on from Zap, we're going to be going to one of these catch blocks, okay? And what are the catch blocks? We're going to look at each catch block in turn and see if they handle this exception in turn. And we go through each successive exception type that's listed. Maybe first we handle null memory, null pointer exception. Then we handle a stack overflow exception. Then we handle a file not found exception, something like that. We go through each one, and if we finally find one that handles it, we do the work with this catch block. And maybe it fixes things up. Maybe it asks the user for extra information. Maybe it goes and gets information on a backup database. But if none of those catch statements catch it properly, none of them handle it, what do we do, ladies and gentlemen? Okay, we actually don't correct. What happens then, if none of the catches in Baz handle it, ladies and gentlemen, then it goes up to bar. It's not getting handled by Baz, okay? It goes up to bar. Now, meanwhile, what's happened is it's rolled back. Baz is no longer around. Baz is no longer around. The call to that is ended. We're never shall we continue on this place in Baz which calls Zap. That's all off the stack. These are gone. Now we're back to bar. And hey, bar, are you going to handle this? Are you going to be handling this? And if bar doesn't handle it, go back to food. And ladies and gentlemen, if food doesn't handle it, where does it go back to? Main. And if main doesn't handle it, what's going to happen? Well, the user is going to get a message. It's going to say unhandled exception. Have you ever gotten that before? Yeah, I think so. Well, you know what happened. I can't guarantee that it was called foo, bar, Baz, and Zap in your case, but known programmers, I wouldn't be surprised if one of them was in there. I was just working with code yesterday. Foo. Don't name your variables. This is for like examples in lecture. It's not for name your variables. Don't name your functions. This is just so I don't have to come up with fancy names. Or would you rather this to be named like foo be named Hornswaggle? and this be named Nincompoop or something like that. Nifty. Okay. I don't hear a Greek chorus, so agreement on that one. So the point is this stack gets rolled back. Okay. So if Zap throws this exception, it disappears. The call to Zap is over. Done. Finito. Okay? It's back to Baz. If Baz doesn't handle it, the call to Baz is over. Finito. Done. Then it goes up to bar. If that doesn't handle it, finito. Done. It's just rolling this back. Never goes to resume. But somewhere in here, there may be a cache that handles it. And actually, ladies and gentlemen, in the newest versions of Java and for a long time in C#, which Java kind of copied in this regard, there's also a thing called final, which is, I'm not going to get into it, but it's a way of cleaning up after yourself for either exceptions or for normal processing. The deal here is you roll the stack up, one thing after the other, until someone can handle it. It'll be kind of as if you as a student, if some weird case happened, if some unusual thing happened to you, you might appeal to me as a professor to handle this case. And I'll consider it, and I may say, well, I'm not sure about this because we need comparable standards across students consideration, so we don't necessarily. Although I'll say I'll go talk with my department undergrad chair, my course, and I'll talk with him, and he may say, well, I don't really know what the best policy is, so I'll talk with the department head. You sort of go up there, and at the end, you might get an email from the dean or something like that saying, your request is approved. I'll get that email too and say, fine, I'm not involved anymore. So it's kind of like, these are like successive layers of people. This is like the dean down here in Maine, and you're appealing, and at some point it's above my head. You're dealing with the dean, you're dealing with my department head. I'm just going to agree with whatever the department head tells me. You don't have to really worry about me anymore, because I'm just going to say, yes, sir, or yes, ma'am, depending on who it is, and do whatever they want. So similarly, these things get rolled back, and you don't have to worry about them anymore. But someone up here hopefully handles it, otherwise the user handles it, which is generally not a pretty case. You don't want your arbitrary user to be faced with a null point to exception in your case. Exceptions, ladies and gentlemen, allow these things to handle it. Now, in many languages these days, there's a whole class of exceptions you have to handle. So in other words, it won't let you in Java for many types of exceptions, not runtime exceptions, but statically handled exceptions. It will actually force you to put these things in here, or to say that your function can throw here. Okay? So in other words, you have to either say, hey, Baz can throw this exception, or it has to actually handle this exception. It needs to do one or the other, or both. It can handle it and throw it in some cases. So exceptions are a very powerful mechanism. I wish I had time to go into them more, but because this course doesn't concentrate on Java, I'm hoping in 270 you've seen some of it, and probably for those who take at 370 you'll have more experience with them. How many people have seen more examples in 270 here? Okay, good. Okay, so we're in good sort of situation here. So if you see a try-catch block, and this try-catch block is doing something like opening a file, the try block is opening a file and reading some information in. One bad thing that can happen that we have no control over is that file can be corrupt. And so we might catch an exception when we have this code that's a number format exception. It says, I don't see a legitimate number here. There's something weird going on here. And we have to be able to handle that. Or maybe there's an index out of bounds exception doing something in here. And we have to be able to handle it. So, ladies and gentlemen, exceptions are a very valuable mechanism. We're just going to finish up our discussion of exceptions here. And I think we'll have to leave assertion here, which is one of the most valuable things where lots of examples. We're going to have to leave that until next time. Ladies and gentlemen, please, come on Thursday. If you can't come on Thursday, watch the video carefully. Assertion mechanisms are one of the single most valuable things you can do to help make your code robust. And we're going to be covering them in depth on Thursday. Let's talk though about exceptions. By the way, I'm not hornswoggle with that. So let's talk about exceptions. So the primary drawback of exceptions is the high performance cost. And students often overplay performance. Ladies and gentlemen, if you're throwing many exceptions per second, this place, if you're throwing even one exception a second or something, it's probably these days with processor speed and so on, it's not going to be hugely problematic at all. In fact, it can be quite fun. Another issue, though, with exceptions in languages like C++, ladies and gentlemen, it's a risk of memory leaks or resource problems. Help me understand what I mean by a resource, a memory leak, or otherwise failing to free up resources. So suppose Baz has called Zap, and Zap has now thrown this exception. Zap was trucking along, and suddenly it's thrown this exception. And now Zap has disappeared, and I'm back at Baz. Why could there be a so-called memory leak? Yeah, Zap was in the middle of a bunch of stuff. It malloc this, it malloc that, and it was doing some work, chunking right along. And some bad things happened. It threw an exception. those calyx and those malix, are those magically free? No. Ladies and gentlemen, if only it were that simple. In C++, they're not freed up automatically. In Java, can they be freed up automatically? Yes. Yes. But in C++, ladies and gentlemen, you're dealing with a lower fund. More is on, the onus is on you to clean up after yourself when it comes to memory. No, this is not, a fatal thing. You can actually, if you're really, really careful about it, you could make it so that you have finally blocks, or you could try catch blocks within ZAP, which clean up after any memory there. There are ways of kind of dealing with this, but it's more mechanism. And if you just blithely throw an exception, don't expect your memory that you've allocated with calloc or malloc or with new in C++ to be cleaned up for you, because by and large it won't be. And so memory may disappear. If you're throwing exceptions frequently, once a second even, which is quite frequent, performance-wise, it may not be a big issue, but you may be losing blocks of memory left and right, and eventually your memory will be exhausted, which is not a fun thing. Not a fun thing. It's another falsehood. Yeah. So you can get memory leaks here. Another thing is it's hard to recognize mistakes in code sometimes because this thing that was going on in ZAP, it bombs out in the middle. When we had Baz calling ZAP in the middle here, this bombs out in the middle. This stuff never gets done here. In the case of the exception. So it's kind of sometimes hard. You look at a block of code, you say, well, if we reach this point, we're definitely going to reach that point. With exceptions, nah, it's not the case. You may bomb out of there at any number of points because of an exception. And even though it looks like so-called straight line code, we go A, B, C, D, E, right in a row, no chance for, if you get to A, you're definitely going to get to E with exceptions. That's not the case. Okay? I'm not going to go into the various subtype rules. It turns out that some languages have really helped clean this up. So in Java, you have so-called garbage collection. People talk about garbage collection. Okay, so the idea is the language keeps track of sort of which memory is really still being used, which things have references to them, and will clean up automatically things that have no references to them, which deals with the vast majority of issues like that. So you don't have to worry about, memory is being leaked when it's throwing exception. A finally block, that's something that handles all things that are going to leave this function, whether by an exception, so when ZAP bombs out, if there's a finally block, it will execute it around it. If it leaves via an exception, it will execute it. If it leaves via regular return code, it will execute it as well. And another thing is in Java, again, if Baz is calling ZAP, and if ZAP can throw an exception, either Baz has to also say, I can throw that exception for most types. Okay. So exceptions are very useful mechanisms. I think, are we at, yeah, we're just a couple minutes before here. So a couple exception recommendations. Handle them as soon as possible, as close to the source as possible. Don't wait for the dean to clean up after you. And you need to sometimes translate the language, because a warning that's clear at the low level for the name of the exception or what it means won't be clear sometimes at higher levels, like for the user. Right. And one thing with exceptions, very important to realize, exceptions include information on where they were thrown from, so where they came from. They include information about sort of where they originated, which can be very, very useful. I think I'll skip that. So ladies and gentlemen, next time we are going to be going on to discussion of assertions, which again is one of the most single valuable sort of practical techniques you can use for building robust programs. Thank you.